Hey everybody, today I want to talk about right triangle trig, specifically SOHCAHTOA. So there's three ways you're going to be able to use this concept in trigonometric ratios. One is to actually find those ratios from a set of side measurements in order to find angles. Two, to find missing side measurements of angles. And three, to find missing side measurements. So with SOHCAHTOA, which is an awesome acronym to help us remember the trigonometric ratios, we have sine, cosine, and tangent, which is the S, C, and T of the acronym of SOHCAHTOA. Sine of theta, that little circle-looking thing with like a squiggly straight line in the middle, that's actually called theta, the Greek letter. It stands for X. It's just our new way of representing angle measurements. And the ratio that sine is the opposite side of the triangle divided by the hypotenuse, or opposite over hypotenuse. Now, if we take a look at SOHCAHTOA, the SO, or SOH, is the sine equals opposite over hypotenuse. Clever, right? Cosine is the same way, but in this one, it's adjacent over hypotenuse, A and H, and tangent, which is opposite over adjacent, O and then A. So it helps us, SOHCAHTOA does, remember what the ratios of these very important trig functions do. Okay, so for our first example, it's asking us to find cosine of x, meaning find the cosine ratio of the angle that starts with x. So this is really the first way that we're going to be able to use SOHCAHTOA to help us find something relationship to trigonometry. So if we have angle x here, I want the cosine or the ratio of that angle. Now we have all three side measurements, which makes this a lot easier. We don't actually have to choose, except for the fact that it said cosine. So what is cosine again? Well, as we see from above, cosine is the adjacent side divided by the hypotenuse. Well, this is going to be x here, our reference angle, or our point that we're going to identify the two sides that we're going to need. So in relationship to x right here, what is the adjacent side? Well, the adjacent side is going to be the side measurement that actually touches or opens up from that angle's perspective, or from that angle's vertex. But as you can see, both 8 and 10 open up from x. But because it's a right triangle, 10 is something actually very special, and 10 is the hypotenuse. Now let's go ahead and label the sides that we know. We know that 8 is adjacent, meaning next door. 6 is going to be opposite because it doesn't touch the side to the angle in any way, shape, or form. So we can label 6 as our opposite side. And then 10, like I had said earlier, that's going to be our hypotenuse. So, let's make this a little bit easier here, huh? H-Y-P. There we go. So, now we can just simply put together the numbers that we need. Cosine, again, is adjacent over hypotenuse, so 8 over 10 is not actually our final answer yet. Because when we talk about fractions, in any sense, we want to simplify them as best we can. So, what does 8 and 10 have in common? Obviously a 2, so we're going to divide by 2 on top and bottom. Cosine of x is going to be the ratio of 4 over 5. Let's try our second example. So in this example, I want to find tangent of z. Very similar to our first example. But this one, I'm looking for the reference angle of z, where that vertex is, and I want tangent. Well, take a look above. Tangent is opposite divided by adjacent. So let's label our side measurements with z as our focal point. Z and 8. Well, that's across the way, and this 8 doesn't touch that angle in any way, shape, or form. So 8 is what we're going to label as our opposite side. 6, because it actually is part of the angle that opens up, is going to be my adjacent side, which leaves 10 as our hypotenuse. But we knew that it was going to be the hypotenuse anyway, because number 1, it's always the longest side of a triangle, and number 2, it's directly across the way, across the street, if you will, from the right angle box, which obviously isn't there. So we can label this as hypotenuse. So tangent of z, again, tangent is opposite over adjacent. So tangent of z is going to be opposite, which is 8, over adjacent, which is 6. So we're going to do 8 over 6. And just like our first example, we have to simplify that fraction. Divide by 2 on top and bottom leaves me with 4/3. So the ratio of tan z is 4 over 3. Okay, so the second pair of examples I have here is really the second way we're going to use SOHCAHTOA and these trig ratios to solve problems. In these two particular problems, I'm looking for the missing angle measurement. So if you have a graphing calculator, a TI-84, that's perfect. If you don't, it's okay. There is a free app called Calculator X84. You can go to the App Store and download it. It's free. It will look, meaning the interface, exactly like the TI-84. So go ahead and get that if you don't have a graphing calculator home. I know most people don't, which is totally fine. If you're in your early years of high school, you might want to go ahead and think about purchasing one. It will last you for a significant amount of time. Calculators aren't like iPhones. They don't just come out with a new version every year. This TI-84 has been around for a couple of years now. Only thing they did was they upgraded it to have a color screen. Okay? So let's go ahead to example 1. Find theta. And again, theta is our measurement for x. So here is our focal point here, theta. Now in these two problems, I'm not giving you every side measurement, which you normally won't have, because the object is you really want to pick which trig function or which trig ratio works best for you. So let's see what we have here. In this problem, theta, I have the opposite side. So I'll label that as opposite. And I have the hypotenuse, because again, take my word for it, they are right triangles. 22 is my hypotenuse. So at this point, we just need to pick the right trig function. O and H is sine, opposite over hypotenuse. But plugging it into the calculator is going to be a little bit tricky. So let's see what we're going to do. We've picked sine. So the problem is going to look like this. Sine of theta is going to equal opposite, which is 7, over hypotenuse, which is 22. But we can't use the calculator in this function. We're going to do something a little bit special. Now the way it's going to look is sine inverse theta equals 7 over 22. Now what does this little inverse mean? Well, it looks like an exponent and it's a negative one. But that just means in the calculator, we're going to open up the inverse functionality, which is the second button. So here's the actual button pressing you're going to be doing for the calculator. Second button. God bless you, Titan. Sine 7 divided by 22. He just sneezed. That was the craziest thing. He's laying there and he's sneezing. Okay, you're going to plug this in the calculator and we're going to solve our problem. Second sine 7 divided by 22. Now, the one thing you want to make sure is that you are on degrees. Sometimes if you haven't done this functionality before, your calculator, especially the TI-84s, are going to default to what's called radians. We don't want that. So let's backpedal for a second, huh? On your calculator, you're going to see a button that says mode. Pressing mode opens up a whole range of different functions for you. The third or fourth line down, depending on what version you're using, it's going to say radians or degrees. Make sure it's highlighted on degrees, hit enter, and then you can clear out and start it again. If you're on radians, radian is obviously a valid measurement, and trigonometrically speaking, that's a word. I just made it up if it wasn't. It is very useful, but when we talk about things like this, it's not going to be something that's really super helpful. So make sure you're on degrees, and we're going to round to the nearest tenth. I'm going to have 18.6 degrees, and that's going to be the angle measurement of theta. Okay, you're back. I know you missed me. It's okay. So if you have this layout here, second tan 13 divided by 10, you're looking good. Obviously, we're going to pick tangent here because we have an opposite side and an adjacent side. This would be the hypotenuse in this right triangle, but there is no measurement there, so we don't need it. Yes, spoiler alert, you obviously could find the hypotenuse if you wanted to using the Pythagorean theorem. I don't know why or on what world you'd want to do that. Why make things more difficult for yourself when you don't need to? So let's plug in second tan 13 divided by 10. If we're rounding to the nearest tenth, we should get 52.4 degrees, which is going to represent the missing angle measurement. Okay, the third and final way you're going to see problems in relationship to SOHCAHTOA is when we have missing sides. This can get a little tricky, so stay with me. We have 3 pieces of information, or 3 things that we either know or want to know. In this particular case, I'm giving you the angle measurement. That is still theta, and we're still going to use that as our reference angle or our beginning point of reference. 15 is going to represent the opposite side measurement. Now, I want to know what the value for x is. I still want that value, even though it's unknown at this point. But because we have our angle measurement, x in relationship to 27 is still adjacent to that angle. So we're still going to play it out like we were trying to solve for the measurement of the angle and see what happens. I have opposite and adjacent, which is tangent. Now let's plug in the numbers like we normally would and see what happens. Tangent, 27 degrees, no longer theta. And the reason for that is because I have the angle measurement. See, remember, theta will always represent my angle measurement. And that's going to equal opposite, which is 15, over adjacent, which is x, just like the ratio tells me. Now, algebraically speaking, as long as we have an equation and we have one variable, we don't have to do anything silly to solve it. We can just use algebra to solve it. So let's go ahead and do that. I've got to get rid of my denominator, so I'm going to multiply by that denominator on both sides. That cancels my denominators, and I'm going to be left with x times tan 27 equals 15. Well, tan 27 is a value just like 15 and just like x. If I'm trying to isolate x, I'm going to divide by tan 27 on both sides, which cancels the tan 27s, and I'm left with x equals 15 over tan 27. Now this is what we're going to be putting in our calculator. One thing to be really careful about. Remember when we did angles in the last slide? We used the second button to get the inverse of that function. When we look for missing sides, we do not use that button. We are just going to plug in specifically 15 divided by sine tan 27. No second button, no inverse, nothing crazy. Just straight up. Let's see what we get. If I'm rounding to the nearest tenth place, which is customary, I'm going to get 29.4, which is going to be our final answer, and it's going to be the measurement of this bottom or adjacent side. Now, let's try that same functionality with example 2. In example 2, again, I'm looking for a missing side measurement. But in this one, I need the hypotenuse. So in relationship to that 52, which is our theta measurement, what am I giving you? 13 is opposite, and x is the hypotenuse. So I have an O and an H. I need sine. So just like the previous problem, sine of 52 is going to equal opposite of 13 over hypotenuse of x. And again, because our x is in the denominator, we're going to have to finagle it just a little bit. Canceling out the x's, x sine 52 equals 13. Dividing by sine 52 on both sides. Oh, that's squeaking. Is that bothering you? That bothers me a little bit. Sorry. 13 divided by sine 52. Rounding to the nearest tenth place is going to give me 16.5. Hopefully you can see that. You cannot see that. 16.5 is going to be my answer for the missing hypotenuse. Now, it's hard to really tell because we don't know this measurement here, but 16.5 is certainly bigger than 13, so we know that we're in the right ballpark anyway, even if we weren't sure of our answer, because we know the hypotenuse has to be the longest side of the triangle. Okay, things to remember about SOHCAHTOA and right triangle trig. Number 1, obviously SOHCAHTOA. Sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite over adjacent. It's a nice little trick to remember SOHCAHTOA. Number 2, inverse trig is used to find missing angles. So whenever we're looking for a theta measurement, or x, depending on what's written there, it's usually theta, but try to get in your head. If I'm looking for an angle, I need to use the second button on my calculator to solve for it. And number 3, regular trig, or non-inverse, or straight up trig, is going to be used to find missing side measurements. Okay? So inverse trig for angles, second button, or just straight up entering in your trig function for sides. See you later.